we're going to do another problem on the mean and the intermediate value theorem. Now, problem 19 says that f is continuous on the closed interval AB and it is differentiable on the open interval AB. That is, it might not be differentiable on the endpoints. And f of A equals to A, f B equals to B. Now, we are supposed to show there exist two distinct points, x1 and x2, which is inside A and B, such that f prime x1, 1 over f prime x1 plus 1 over f prime x2 equals to 2. And remember, this has to be, this is not A or B, okay? That's the condition. So we have distinct points. Now, how would you, to prove this, we will use both the intermediate value theorem and the mean value theorem. Plus, we'll also use a specific trick. Otherwise, if you look at this and there are 2 points and you're wondering how would you be able to come up with 2 points, because the intermediate value theorem is talking about 1 point only. So you're going to pull a trick like this. What you do is you choose a point. Consider well, first we'll draw the graph of the picture. F is this is A. F of A equals to A, and F of B equals to B, and then F will go its way around, and then so this is A, and this is also A, right here, and this is B. And this is also up here is also B. What we're going to do is find the midpoint of this thing, which is called A plus B over 2. And we're going to do algebra on it. And this is the hint that you pretty much have to use in order to get this thing to come out. So A plus, we will use by the intermediate value theorem. There exists a U where, okay, now we will draw it here. This is U. There exists U such that f of U equals to A plus B over 2. All right, well, so far so good. But what does that take us? Next, we're going to use the mean value theorem. By the mean value theorem, there exists x1 and x2. So here's where it comes from. x1, x2, where we will do mean value theorem on this part and then on this part, where f such that f prime of x1 equals to the first part is A plus this thing minus A over U minus A. And I'm quoting where x1 is in between A and B. Okay, where x1 is between, I mean not between A and B, but between A and A plus B over 2. This is just reciting the mean value theorem. And similarly, for the second section, we will use the mean value theorem to say that f prime, there exists x2, where f prime of x2 is, you do the B part. It's B minus A plus B over 2 divided by B minus U. And all right, so all of that is looking decent. And now we're just going to use algebra to crank this thing out. This will come out if you do all the stuff. So what you do, of course, is you have to now do algebra now. So there's no getting around it. So you clean this up a little bit. You have f prime of x1 equals to, we'll write it like this, U minus A. And then this thing minus A will become B minus A over 2. Okay, by the time you clean up the algebra in here. And similarly, f prime of x2 equals to 1 over B minus U times same thing. This thing, when it comes out, it will become B minus A over 2. And then you add this stuff together, so 1 over f prime of x1 plus 1 over f prime of x2 is equal to, so now you have to flip it around, so you have something like 2 times u minus a over b minus a plus 2 times b minus u over b minus a, which is, when you clean up all the algebra, u minus a and then b minus u, so the u is out, you're left with b minus a, which cancel out with the bottom. All said and told, you will get 2 out of this particular mess. And that's the solution. The problem looks really cryptic when you first look at it, but with the hint, then everything comes out very nicely, and you're using both theorems, and that gives a powerful and yet elegant solution to this problem.